So this lesson is going to cover two more forms of linear equations. It's going to go a little deeper into standard form, which we're already familiar with, and then it's also going to cover point-slope form, which we haven't previously talked about this year. So we're just going to get started. For the standard form, what it's doing is it's showing you how a real-world situation with two variable components can be placed into a standard form equation. When we do that, the coefficients of the two variables, so we have our standard form ax plus by equals c, and so we're talking about these coefficients here. They actually serve almost like rates that correspond to the two unknown variables. So if we look at this example, Sarah's Soy Candles Inc. has 240 candles which need to be shipped to various stores. Sarah will use small boxes which hold 16 candles and large boxes which hold 20 candles each. Write an equation in standard form that models the number of small and large boxes that Sarah might use. The idea here is that she's able to use different combinations of small and large boxes to ship these 240 candles. But the 240 is going to be a constraint. So we talked about that word constraint, where it means that it has to meet this particular parameter. No matter what combination of small and large boxes we use, whether we use one small box or 10 small boxes, when we put them all together, they have to hold those 240 candles. So make sure you understand the point of what we're trying to do here. It says write an equation in standard form that models the number of small and large boxes. So those are going to be our two variables. In a case like this, it does not matter which one you assign x and which one you assign y. The reason being, normally, we talk a lot about the idea of which one is dependent, which one is independent. Your dependent variable is always your y, your independent is always your x. But in this case, it can go either way. If you choose to use two small boxes, then the number of large boxes you need is going to be dependent on that choice. Or if you choose first to use X number of large boxes, then the number of small boxes you need is dependent on that choice. So it can really go either way. So we'll just go in the order it's given in the problem. We're going to call the small boxes X and the large boxes Y. Okay, so now we've defined our variables. Other information that we have in this problem that we're going to need to use is the fact that the small boxes hold 16 candles each and the large boxes hold 20 candles each. That's going to be the rate at which we fill each box, each type of box. And then of course we have our constraint of 240 total candles. So if we know that X represents the number of small boxes we're going to use and that each one holds 16 candles, then we can represent the total number of candles that are put into small boxes by using the coefficient 16 and the variable X as our first term. And then we're going to add to that the number of candles, total number of candles that are packed into large boxes. That can be represented by the rate of 20 candles per large box, or 20 times y. And then of course we have our constraint that altogether that has to equal 240. So that's where our constant's going to go. That doesn't change. No matter how many small or large boxes we use, we have to pack 240 candles. So it makes sense that that's our constant. So now we have an equation that's almost in standard form. If you remember our rules for standard form, A has to be a positive whole number integer, or whole number coefficient, and also there cannot be any common factors between A, B, and C. And so that's where we need to go ahead and finish simplifying, because I do see that they have common factors. Looks like we can reduce each one by 4. So let's do some division here. Just make sure you distribute it to all three terms in that equation, and that gives us 4x plus 5y equals 60. And that's our reduced form of the standard equation. So we've met the goal of the problem. We have a linear equation in standard form that represents the scenario of the candles in the boxes. And then our next goal is going to be to graph it. So to review, the way that we want to graph equations when they're in standard form is to use the x and the y intercepts. To find our x-intercept, if you remember, any point on the x-axis has a y-coordinate of 0, a y value at 0. So to find our x-intercept, we're going to substitute a 0 for the y variable, and then we're just going to solve. So 4x plus 5 times 0 is 0 equals 60. And then we divide to solve. and x equals 15. Okay, so basically that tells us that we have a point at 15, 0, our x-intercept. And if we think of this in terms of the problem itself, remember that x is our small boxes and y is our large boxes. This point represents the fact that if we want to, we could use 15 small boxes and 0 large boxes. And we would pack all 240 candles and ship them out to 15 different stores. That's one possibility. Now, to find our y-intercept, we're going to do the opposite, because the points on the y-axis have an x value of 0. So we're going to plug in a 0 for the x term this time. 4 times 0 is 0, plus 5y equals 60. Divide to solve, and y equals 12, which gives us a point at 0, 12, right here. And if we think in terms of the problem, that means that we could use 12 of those large boxes and 0 small boxes, and that would hold all 240 candles, and we could ship them off and we'd be done. But because this is an equation where there's several different possibilities, we want to represent them all. And so what we're going to do to represent them all is we're going to connect these two intercepts into a straight line to represent that linear relationship between them. So I'll go ahead and get my ruler out and just connect my intercepts to create my line. Go a little bit bolder so you can see it. There we go. Okay, so then any point on that line could represent a combination of small and large boxes that we could use. So for example, it looks like we could use 7 small boxes and 6 large boxes. Or we can also represent this with the equation. We can say, okay, well, if I use 10 small boxes, then how many large boxes would I need? Well, we can use the equation to figure that out. 4 times 10 small boxes plus 5 large boxes. And then we would just solve again. 60. And subtract. And divide. And we would need 4 of those large boxes. So if we use 10 small boxes, we need 4 large boxes. And you can see that that corresponds to a point on this line right here. So any of those combinations would correspond to the points along that line. Okay. The other type of linear equation, the other form of a linear equation that we're going to look at is the point-slope form of a linear equation. So this is a little bit new. You may have seen it last year, but basically it comes from the slope formula, the idea that y minus y, or y2 minus y1 over x2 minus x1 equals m. And if you want to see an explanation of how we get from slope formula to the point-slope form of a linear equation, I've linked the Khan Academy video. He explains it really well, basically the idea behind the point-slope form. But here's the point-slope form of a linear equation. I'm going to get rid of this so it doesn't confuse anybody. It is y minus y1 equals m times x minus x1. In this equation, of course, we all know that m is slope. Okay, m is always slope. x1 and y1 are a point on the line. So x1 comma y1 is a point, a given point on the line. And the x and the y that do not have the subscript, they represent any other point on the line. They're going to remain variables, and so they're going to be variables that represent any other point along that line that the equation is modeling. Okay, so for example, if I want to write an equation for a line with a slope, a given slope of -1/2, and a point at, let's say, -3, 4. I can use my point slope form to do that. We learned earlier today, or yesterday, I'm sorry, how to use the slope-intercept form to write the equation given a point and any, the slope and any point on the line. But this is just another form that we can use. And so to use this, we're going to keep our y variable, but when we say minus y1, we're going to use the y1 from the point. And so in this case, it's a positive 4, so minus positive 4. And then insert your 1/2, negative 1/2 for the slope. That first x that doesn't have a subscript is a variable, so it stays an x. But when we say minus x sub 1, that's the one from our point, which is a negative 3 in this case. And of course, minus a negative 3 is going to become plus a positive 3. And so this, and I'll go ahead and simplify that. This is the point slope form, okay? Point slope form of that line. And then we can very simply transition from point slope form back into y-intercept form or standard form, whichever we need, just by simplifying this equation. So all we need to do is go ahead and distribute our negative 1/2. So now we have y minus 4 equals negative 1/2 x minus 3/2. And then we just want to take the constant here on the y side and move it over to the x side so that y is by itself, because remember that in slope-intercept form, y is alone over there, isolated. So we're going to do plus 4 and plus 4, and that gives us y equals negative 1/2 x minus, looks like 5 oh nope, that's a plus, sorry, plus 2 1/2. And that's it. So we've gone from point slope form and then the equivalent linear equation in slope-intercept form. On your homework assignment in Teams, I've linked the Khan Academy lessons for both of these concepts and some videos in practice that I want you to work through. If you have not joined the course on Khan Academy yet, then I will also drop the links right into the Teams chat so you can just go to them directly. And you will have till next Wednesday to finish that assignment. Thanks.